Now in this lecture, we are going to see two more methods to solve the numerical integration, and that are known as Simpson's rule. Okay, so we'll just recall what we have done yesterday. We saw what are the methods or how to solve the numerical integration. If you are given the integration from a to b f of x dx, and if we know the value of the function f of x for different values of x, say x0, x1 up to xn, these are equispaced value, and the difference between any two successive values of x is h, that we call as a width. Okay, and these are called as a subinterval. X0 to x1 is a subinterval, x1 to x2, x3 to x4, like that. These are the subintervals of main interval AB. A is the lower limit of the integral and B is the upper limit. We divide this main interval into n subintervals of width h. So what is the relation between this AB, n and h? If we take the subtraction of upper limit minus lower limit divided by total number of subinterval, that gives us h. So x1 will be x0 plus h, x2 will be x1 plus h. So xn will be xn minus 1 plus h, or x0 plus nh. Okay, so if we know the values of this function f of x for these values of x0 to xn, then by using standard formulas, we can solve this integration. And last time we have taken the first formula, that was trapezoidal rule. Okay, it is h by 2 into bracket y0 plus yn plus 2 times addition of rest of the values of y. And making use of that simple formula, we can easily solve this integration. Okay, now we'll see two more formulas, two more method to solve such type of numerical integration. The first one is Simpson's 1/3 rule. Now what is this Simpson's 1/3 rule? If the number of interval is divided into even number of subintervals, okay, for example, n must be even, okay, then the value of the integration from a to b y dx is equal to h by 3 y0 plus yn plus 2 times addition of all even terms of y, that is y2, y4 up to yn minus 2, plus 4 times all odd values of y, that is y1 plus y3 plus dot 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 yn minus 3, okay, yn minus 1. Okay, so we must have for Simpson's 1/3 rule, there is one condition, that is the number of intervals must be even, number of subintervals must be even, n must be even. Then divide this a to b into n even number of subintervals. Then at each value of x0 to xn, find a value of y, that is y0 to yn. Then h by 3 into y0 plus yn plus 2 times all even values of y. Even values of y means y2, y4 up to yn minus 2 plus 4 times add all odd values of y, y1, y3 dot 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 yn minus 1. This is n minus 1. By mistake I have taken n minus 2. This is y n minus 1. Okay, and just simple calculation gives us the answer. Okay, so only this formula we have to remember, simple formula and the condition. Okay? There is restriction for the Simpson's rule. The interval must be even in number, subinterval must be even, n must be even. For trapezoidal rule, there is no such condition. N may be even or odd, no problem. But for Simpson's rule, the subintervals must be even. Okay, now we'll take problem and we'll see how to make use of this simple formula to solve any complicated integration. So consider the first problem. Integrate approximately integral 1 to 7 f of x dx by using Simpson's one-third rule for the following data. Values of x are 1, 2, 3, 4, 5, 6, and 7. And value of the function f of x is 2.157, 3.159, 4.198, 4.539, 4.708, 4.792, and 4.835. Okay, so values of x and the values of f of x, that is y, are given in the table. We just have to use the Simpson's formula, and then by simplifying we get the term. This first term is x0, x1, x2, x3, x4, x5, and this is x6. So n is 6. Total number of term minus 1 is n, because the first term start with 0, x0, x1. So the total number of terms minus 1 gives us the value of n. Okay, for statistics, we take total number of terms as n, but for numerical, we take total number of terms minus 1 as n, because here calculations start with 0 terms, x0, x1, x2, like that. Okay, so these are the values of x, these are the values of y. This is y0, y1, y2, y3, y4, y5, and this last term is y6. Okay, so use the one-third rule. The difference between any two values. Okay, you take any two successive terms, the difference between them is 1. So h is 1. N is total number of terms minus 1, that is 6. Okay, so by Simpson's one-third rule, integration from 1 to 7 f of x dx is equal to h by 3 y0 plus yn plus 2 times even values of y, y2, y4 up to yn minus 2 plus 4 times odd values y1, y3 plus yn minus 1. Okay, now put the values, first value plus last value of y, 2 times even terms y2, y4, like that. So this is y0, y1, this is y2, this is y2, this is y4. Okay, this value already taken, so don't take that last values again. So by using these tabular values, h is 1, 3 as it is, first term and last term, addition of first and last term, that is 2.157 plus 4.835 plus 2 times. After taking first and last, don't again calculate that. It will be 2 times y2. Y2 is 4.198. Then y4, that is 4.708 plus 4 times odd values. This is y0, this is y1. So y1 is 3.159 plus y3 4.539 plus y5 4.792. Okay, so after taking first and last, 2 times even terms y2, y4 plus 4 times odd terms y1, y3, y5, like that. And this simple calculation gives us the answer. 1 by 3 into 6.992 plus 17.812 plus 49.96. And if you calculate, it gives us the answer 24.921. Okay, so very easy. Just properly remember the formula. 2 times even terms, carefully take first term as y0, second as y1, y2, y3, like that. Terms are there. So 2 times even suffixes of y, 4 times even suffixes y with the odd suffixes. Okay, this is y n minus 1. By mistake I have taken n minus 2, it is y n minus 1. Okay, so by taking that values, doing the simple calculation gives us the value of the integration. Okay, so just by using this tabular values, we can get the answer. Now consider the next problem. Evaluate integral 0 to pi by 2 square root of sine x dx by using Simpson's 1/3 rule, take n is equal to 6. Okay. Now, for using Simpson's rule, we need table. So we have to prepare a table. We know what is n. We know the limits of the function. We know limits of the integration. We know what is a function inside the integral. So take this function inside the integral as f of x. A is 0, b is pi by 2. Take n as 6. By that we can get h. N is 6. F of x is square root of h is equal to pi by 2 minus 0 divided by 6. So it will be pi by 12. Okay. Lower limit is x0 and this upper limit is xn, that is x6. So in between values we have to find. So how to find the values? X1 will be x0 plus h. X2 will be x1 plus h. X3 will be x2 plus h. So take this as h, take x0 as 0 and reach up to pi by 2. At each term, add pi by 12. And at each value of that x0 to xn, find a value of this function f of x. Okay, because f of x means y. So we want what is y0, y1 up to y6. So how to get that values? Put that values of x0, x2 up to x6 into this function and then do the calculation. Whenever we are having a trigonometric term in the function, always do the calculation in radian mode. On calculator, while doing the calculation with trigonometric term, always choose radian mode. There are different modes, degree or radian. Okay, so for trigonometric term, don't forget to choose radian mode. Okay, so using radian mode, x0 is 0, x0 is 0, x1 will be x0 plus h, 0 plus pi by 12. X2 will be pi by 12 plus pi by 12. That becomes 2 pi by 12. 2 pi by 12 is nothing but pi by 6. Next term will be x2 plus pi by 12. So it is pi by 6 plus pi by 12. Add pi by 12 to this, we get next term. Add pi by 12 to this, we get next term. And like that, continue until we get this upper limit. Upper limit is pi by 2. Okay, so there are total 0 up to pi by 2. We have to divide it into these many intervals, 6 sub-intervals. Now, put this x equal to 0 into this function. Get the value of the function. Put x equal to pi by 12. Find sine pi by 12. Square root of that gives us this answer. Substitute x equal to pi by 6. Sine pi by 6. Square root of that. And complete this table. Okay. So these are the values of x0, x1, x2, x3, x4, x5, and x6. And these are the values of y0, y1, y2, y3, y4, y5, and y6. y6 is 1. And it is asked to use Simpson's 1/3 rule. So making use of the standard formula, integration, given integration will be h by 3 y0 plus yn plus 2 times even suffix terms of y, y2, y4 plus yn minus 2 plus 4 times odd suffix of y, that is y1, y3 up to yn minus 1. Okay, so take y0 and yn, first and last term, 0 plus 1 plus 2 times even terms, y0, y1, y2. y2 is 0.167 plus y4 is 0.931 plus 4 times odd suffix terms of y. This is y0, this is y1. Second term is y1. So it is 0.509 plus y3 is 0.841 plus y5 is 0.983. Okay. Now do the simple calculation, just addition and multiplication by these terms gives us the answer. So after simplification, substituting the value of pi and doing the calculation with all these terms, it gives us answer 1.078. So without knowing what is the formula for integration of sin x, still we got the value of the integration. Otherwise, solving the integration of square root of sin x directly, it is quite difficult. But by using this numerical method, okay, by using this tabular values, we can easily get the approximate value. Okay, the only thing for the Simpson's 1/3 rule is n must be even. For odd n, this formula is not useful. Only for even values of subintervals, we can use this formula. Okay. Now, similar to this, we are having one more rule, that is Simpson's 3/8 rule. Now, what is this Simpson's 3/8 rule? If the number of subintervals are divisible by 3, now what do you mean by divisible by 3? N must be either 3, 6, 9, 12, 15. That is, it is a divisible by 3. Then the value of the integration is given by 3h by 8 y0 plus yn, first plus last value, plus 2 times y3, y6, y9 plus yn minus 3. That is all multiples of 3 suffixes of y. 3, 6, 9, 12, all that multiples of 3, plus 3 times all the remaining terms, first, last, and multiples of 3, except that whatever terms remain, y1, y2, y4, y5, y6, y7, y8, like that, whatever remaining terms, addition of that into 3. Okay, all this term gives us the value of the integration. Okay, so carefully remember this formula. What we have done, 3 by 8, because here here the coefficient is 3 by 8. For 1/3 rule, we are having h by 3. For 3/8 rule, we are having 3h by 8. Okay, so that is how we can easily remember what is the coefficient. For 1/3, h by 3 only, and 3/8 rule, 3h by 8. Important condition to remember for Simpson's 3/8 rule is the subinterval n must be divisible by 3. 3, 6, 9, like that, we must have the terms, number of subintervals. Then formula is add first and last value of y plus 2 times take the values of y whose suffix is divisible by 3. y3, y6, y9, y12, like that, add all that terms plus 3 times all the remaining terms except first, last, and divisible by 3. Other than that, whatever terms are there, add them and multiply it by 3. Okay, so very easy and very important formula to find a integration. Okay, this is more accurate than 1/3 and trapezoidal rule, but the restriction for this is the subintervals must be divisible by 3. That is the condition. Okay, so we'll take a problem based on it. Integrate approximately integral 4 to 5.2 f of x dx by using Simpson's 3/8 rule for the following data. Values of x are 4.0, 4.2, 4.4, 4.6, 4.8, 5.0, 5.2, and the function f of x at that corresponding values of x are 1.3863, 1.4351, 1.4816, 1.5261, 1.5686, 1.6094, and last value 1.6487. Now, what we need to compute integration for Simpson's 3/8 rule, we need h, we need y values of y0, y1, y2 up to yn. Okay, so first check what is the difference between the values of x, 4 and 4.2. Difference between these two is 0.2. You take any two successive terms, difference between that is h. So if we take subtraction of these two terms, it gives us 0.2. So h is 0.2. This is x0, x1, x2, x3, x4, x5, and x6. So n is 6. Total number of term minus 1 will be n. So n will be 6. And it is a multiple of 3. So we can use 3/8 rule. So h is 0.2, n is 6. And by using 3/8 rule, integration from a to b, y dx, you can use y or f of x, no problem. Integral a to b y dx is equal to 3h by 8, addition of first and last value of y plus 2 times multiples of 3 suffixes of y plus 3 times all the remaining y terms. Okay, so properly take the values of y. Y0 is 1.3863, yn, that is y6, that is the last value, 1.6487, 2 times multiples of 3, y3, y1, y0, y1, y2, y3. Y3 is 1.5261, y4, y5, y6, but y6 is already considered as a last term, so doesn't have to consider it again. So only 2 times y3 will come plus 3 times y1, y2 plus y1 plus y2 plus y4 plus y5. Okay, so it will be 3 into h, that is 0.2 divided by 8, addition of first and last value of y plus 2 times multiple of 3 suffix of y, y3. Next is y6, but y6 is already considered in this as a last term, so no need to again take it over here. Only y3 will come plus 3 times y1, y2. Y1 is this 1.4351, y2 is this, y3 is already taken here, so remaining term y4, y5. Okay, so add this. Simple calculations are there. On calculator, doing this calculation, you can easily get the value of the integration. So the value of the integration is 1.8263. Okay, so without knowing the actual function, just by knowing the tabular values of x and function, we integration. Okay, and very simple formula is there. Just properly remember the terms. Don't miss out with any coefficients. Don't miss. Just properly take what is y0, y1, y2, all that terms, and put it into standard formula. And simple calculation, very simple calculations are there. Making use of that, we can get the answer. Okay. Consider the next problem. Evaluate integral 0.2 to 1.4 sin x minus log x plus e raised to x dx by Simpson's 3/8 rule. Take n equal to 12. Okay, n is given as 12. Now 12 is a multiple of 3. You can 12 get divided by 3. So Simpson's 3/8 rule is applicable. Okay. Now here trigonometric term is there, sine. So we have to use do the calculation in radian mode. ln means natural log to the base e. If we are having log, then it is a log to the base 10. ln function is available on calculator, so we can easily find that term. Now for finding using Simpson's 3/8 rule, we need tabular values. So we have to prepare a table. For preparing a table, we need values for x0, x1 up to xn. And for finding the values of x, we need what is n, we need what is h, and what is the x0. x0 is 0.2, xn is 1.4. Difference between the 1.4 and 0.2 divided by n will be h. Okay, so n is 12. Take all this function as f of x. H will be upper limit minus lower limit divided by n. So h will be 0.1. So start with 0.2 add h into that until we reach up to 1.4. And at each value of that x, find the value of the function and complete the table. So start with x naught. X naught is 0.2. X1 will be 0.2 plus 1. X2 will be 0.2 plus 0.1 plus 0.1. Like that, we have to continue until we reach up to 1.4. 1.4 is xn, that is x12. And each point find value of this function using calculator. Okay, so that table is at 0.2, starting with 0.2. 0.2 plus 0.1 is this. 0.3 plus 0.1 is 0.4, and continuing until we reach up to upper limit 1.4. You can see there are total n plus 1. There must be 13 terms. This will be x0, x1, x2 up to x12. Put this x into this function. Sine of 0.2 minus log of 0.2 plus e raised to 0.2. That gives us this term. Do the same thing for 0.3. Put x equal to 0.3 into this and get the values. Okay. On calculator, you can set a function, and by using calculate button, you can put a variable x, and using calculate button, just putting these values, you can easily find these rest of the terms. Okay. Now after getting a table, use the formula of Simpson's 3/8 rule. So by 3/8 rule, all that integration will be 3h by 8, first value plus last value, plus 2 times y3, y6, or all the multiples of 3 suffix of y, plus 3 times remaining values of y. Okay, so first value is 3.029, last value is 4.37. Then we have to take y0, y1, y2, y3, y3, then y6, then y9. Y12 is already considered. So 2 times we get 3 terms, y3, y6, y9, and plus 3 times y1, y2, y4, y5, y7, y8, then y10, y11. Okay, all that terms will get. So put it into standard formula and simplify the terms. The simple substitution is there. So it is 3h by 8, h is 0.1, first last value plus 2 times y3, y6, y9, plus 3 times y1, y2, plus y4, y5, plus y7, y8, plus y10, y11. Okay, and doing this simple calculation, simplifying the terms, we can get the value of the integration. So value of the integration is 4.0384. Okay, so these are the 3 different ways: trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule, by which we can easily solve the integration. Okay, Simpson's 3/8 use only when if we are having the value of n as a multiple of 3. If we are having even values of n, then Simpson's 1/3 is used, and there is no restriction for trapezoidal rule. If you are having even multiple of 3, that is 6 or 12, then all the 3 rules are applicable over there. Okay, if it is an even multiple of 3, because if even multiple, so multiple of 3, so 3/8 rule is applicable. As it is even, 1/3 rule is applicable, and trapezoidal is used for any of the interval. Okay, so using this rule, we can easily solve numerical integration. Now, next part is solution of ordinary differential equation. Okay, how to use numerical techniques to solve differential equation, first order ordinary differential equation. Now we know that in day-to-day life or in any experiment, we always come across a differential equation. Okay, because differential equation means what? An equation which contains derivative, and derivative means what? Rate of change of one variable with respect to other variable. And in daily things, the system is always changing with respect to something. Either it may be with respect to time or displacement or any other variable. So always we get a differential equation from any system. But we also know the different method to solve them. Okay, how to solve first order first degree or how to solve higher order differential equation, that we know. But many times we have a complicated differential equation. In solving them by direct method is difficult. So what are the numerical way to solve them? We are going to see there are four different ways. That is Euler's method, modified Euler's method, then Runge-Kutta method, and Predictor-Corrector method. So by using this method, by doing calculation, by using the new iterations, we can find the solution of ordinary differential equation. No complementary function, no particular integral. Without knowing that, we can easily get the solution of ordinary differential equation. So one by one, we're going to see these four different methods. So today we'll discuss the first method, Euler's method. Suppose we have a first order differential equation, which is written in the form dy by dx equal to some function. And if we know the value of function, if we know the value of y at some initial point, say x naught, and it is denoted by y naught, then if you want to find the value of y, what do you mean by solution of a differential equation? Solution of a differential equation means value of y at x, equation of y in terms of x. So if you want to find the value of y at some x, then take that x as xn. Take that x as xn. And xn, we can write it as x naught plus nh. Okay, n is the number of subinterval and h is the width. So take the initial point given in the problem, then at whatever point we want to find y. Okay, at whatever point we want to find y, take that as xn. Then from x naught to xn, reach by dividing it into n subintervals, taking the width h. And then by using Euler's formula, we can reach up to yn. We want to find y at xn. Y at xn means yn. So y1 will be y naught plus h into f of x naught y naught. Y2 will be y1 plus h into f of x1 y1. Like that continue, and we can reach up to yn, that will be yn minus 1 plus h into f of xn minus 1 yn minus 1. So it is very easy. Just carefully understand the meaning. We are given dy by dx equal to some function. That is the first order ordinary differential equation. It can be always written in such form. So whatever function on right hand side, by equating dy by dx equal to something, take that function as f of xy. Initial point is given. Then at which at which point y is given, take that point as x naught, and that value of y as y naught. And at which point we want to find y, it is asked to find y at some point x, take that x as xn. Then from x naught to xn, divide it into n equal intervals, n subintervals with width h. And then at each value, x naught, x1, x2 up to xn, find the value of y by using this formula. This is a very simple formula. Y1 equal to y naught plus h, f of x naught y naught. Y2, take y1 plus h, f of x1 y1. Yn, take yn minus 1 plus h, f of xn minus 1 yn minus 1. We can find these values of f from this function. H, it is width, and y we get at each step from the previous term. Okay, so very easy and simple calculations we have to do to get the answer. Okay, we'll take a problem and then understand how to make use of it. Evaluate value of y at 0.06 by using Euler's method if y dash is equal to x square plus y of 0 equal to 1, and h is given as 0.02. Okay, so firstly y dash means dy by dx, and that we consider as f of x. So f of x is given to us, h is given to us, x naught is given, y naught is given, and we want to find it at 0.06. So this is the value of xn. Okay, so making use of these things, we have to solve this first order differential equation. So considering y dash means dy by dx, that is given as x square plus y, and it is nothing but f of xy. So f of xy is x square plus y. Okay, now what is given? Y of 0 is 1. So 0 is value of x naught. Initial value at which value of y is given, that point is x naught. And that value of y is y naught. So x naught is 0, y naught is 1. H is 0.02. Okay. Take xn as 0.06. Okay. So what will be x1? X1 will be x naught plus h. It will be x naught is 0 plus h is 0.02. Okay, and then find a value of y1, value of y at this point 0.02. So y1 will be y naught plus h into f of x naught y naught. We know what is y naught. Y naught is 1. H we know. Function also we know. So replace x by x naught and y by y naught in that function. Okay, so y will be value of y at 0.02, that is y1 is 1.02 into x naught. X naught is 0, that is 0 square plus value of y is 1. So 0 square plus 1. We are putting x naught y naught into this function. Okay, simplify it. So y1 will be 1.02. But what we want y of 0.06. We got y of 0.02. So we have to do further calculations. So next term will be x2. We got x1. Now take x2. We have to continue until we get 0.06. X become 0.06. Previously it was 0. Then we got 0.02. Now we got 0.04. So we have to continue until we reach up to this point, 0.06. Okay. Now take x2 as x1 plus h or x naught plus 2h. Anything you can do. That will be one and the same. It is 0.04. Use this x2. Find y2 by using Euler's formula. So y2 will be y1 plus h into f of x1 y1. Substitute y1, x1 and h into this formula. So value of y at 0.04 is y1 is 1.02, h is 0.2, function is x square plus y, but x we have to take as x1, so it is 0.02 square plus y1 we have to take it as 1.02. Simplify it. So calculating this value, it will be 1.0404. Okay, but we doesn't want y of 0.04, we want y of 0.06. So find the next value of x. Next value of x will be x3, that will be x2 plus h, that will be 0.04 plus 0.02, that will be 0.06. And now use the Euler's formula. By that we get y3, that is y at 0.06. So it will be y2 plus h into f of x2 y2. And then put the value of all these terms into that and simplify it to get the answer. Okay, so y3 will be y2 plus h x2 y2. So y of 0.06 will be y2 is 1.0404, h is 0.02. Substituting x2 and y2 into the function. Do the simple calculation. So y at 0.6 will be 1.0612. That is what we want. Y at 0.06, sorry, this is here it is written correct. Here it is 0.06. So it is 1.0612. Okay. So by using that simple formula, start with the initial point, add h at every step, and continue until we get the uh, required term, required point, and find the value of y at that point gives us the answer. Okay, so it is very easy. Just understand the meaning of each term and how to do the calculation. That is very important. Now consider the last problem. Find y at 1.5 by using Euler's method if y dash is equal to y square minus y by x, where y of 1 is equal to 1 and h will be 0.1. Okay, so we are given the function y dash means dy by dx, that is we consider as f of x. So this is f of x, y square minus y by x, that is f of x. Y at 1 is 1, so value of x naught is 1 and value of y naught is also 1 and h is 0.1. Okay, y of 1 is 1, so this value is x naught, value of y naught 1 and h is 0.1. So start with x naught, add h into it and continue adding h until we reach up to 1.5. So firstly, x1 will be 1 plus 0.1, that will be 1.1. Find the value of y at that point. Then again add 0.1 to it. Find y at that point. Again add. Continue until we reach up to 1.5. Okay, and value of y at that point gives us the answer. So first take x1. x1 will be x naught plus h. x naught is 1. h is 0.1. So it is 1.1. And use Euler's formula. y1 is y naught plus h into f of x naught y naught. We know what is y naught, 1. H also we know. X naught y naught we know. So put it into this function and simplify it. Okay. So y1, that is y at 1.1 is 1 plus 0.1 into 1 square minus 1 by 1. This will be 0, 0 into this will be 0, plus 1 will be 1. So y1 is 1. But we want 1.5. We got 1.1. So take the next value of x, x2. x2 will be x1 plus h. 1.1 plus 0.1, that will be 1.2. So find the value of y at this point. So y2 will be y1 plus h into f of x1 y1. Put y1 x1 into this equation and simplify it. So that gives us y2 as 1.0091. But we doesn't want 1.2, we want 1.5. So again take the next x, x3 will be x2 plus h, that will be 1.2 plus 0.1, that is 1.3. Find the value of y at that point. y3 will be y2 plus h into f of x2 y2. Do the substitution and simple calculation we have to do. Whatever function is given in the problem, put x2 and y2 in that function and do the calculation. So we get y at 1.3 as 0.992. We want 1.5, so again we have to do the calculation for next x. That is, we have to find y4. x4 will be 1.4 and y4 will be y3 plus h into f of x3 y3. And then put x3 y3 into that function and simplify it. That gives us y4. So y4 is y at 1.4, 0.9594. But we want 1.5, that is one more iteration we have to do. So find the next x, x5, it is 1.4 plus 0.1, that is 1.5. And the value of y at that point will be y4 plus h into f of x4 y4. And then substituting the value, doing the calculation, it gives us value of y at 1.5 is 0.9055. Okay, so at what point we want to get the answer. Okay, up to that we have to continue. Up to that we have to find the values of x, and then using Euler's formula we can get the value of y at that point. Okay, if it is asked up to 1.6, then we take one more term. If it is asked up to 1.3 only, then this is the answer. Okay, so according to what term we want into x, we have to add that h every time, and simplifying it, we can get the answer.